I am Muneer Salim. I am a structural engineer by profession. I have chosen this profession not because it's by interest, it was by choice. From my right childhood, I used to visit all those big structures. That passion brought me to this field of structural engineering. So I have been a graduate from civil engineering from Anna University. I did my graduation in the year 2018. Since then, I have been working as a structural engineer in Unique Builders in Trivandrum. Last year, I got the opportunity to work in this company, eConstruct Private Limited, as a structural engineer. I have been exposed to a lot of mega projects like up to G+24 Residential Building in Mumbai. So I have gone through a lot of experience. I got to learn a lot of things about this field, like many complex structural engineering principles, lot of the many analysis that's happening behind the scenes. So I will be shortly explaining about whatever I have done in my projects and those things what I have gone through my portfolio. So coming to my portfolio. So this is my portfolio and this is my cover letter. So I have been a structural engineer for last 5 years and almost delivered like 20 plus projects. And this is my education background, this is my professional background. And coming to my skills and proficiencies, I have developed well software skills in softwares like AutoCAD, ETABS, SAFE, STAADPro, Revit, RCDC, MS Office. Coming to language skills, I have been good, fluent in English. Other than English, I am good at in Hindi and little bit Arabic, up to some extent like German, and surely my native language Malayalam. Other than that, I'm good at communication skills. I have good like project management skills too. Coming to the projects that I have done, it's like G+24 Mumbai projects, G+16 Mumbai projects, like G+12, G+8, up to G+2, G+3. Then other than that, I have done like retrofitting projects, steel building, PEB structures. So coming on to the things that I have now. This is a short summary about myself. So I am well at RCC structures. I have knowledge about steel structures. I have done composite structures, even though retrofitting structures. Coming to other things like foundation design, like raft, pile, software knowledge. Other than that, I have good knowledge about the codal provisions, then the conceptual understanding. Coming to the fundamentals like response spectrum analysis, model analysis. These are the complex analysis that is taking place behind the scenes in every structural engineering projects. Coming to dynamic analysis, P delta, creep, auto construction, time history analysis. These are the codes that I'm well efficient of, like IS 456, 1893, seismic design, IS 18875, 13920, ductile detailing, 16700, tall building. Then coming to my soft skills, I am good at communication. I have like analytical skills, problem solving skills, logical thinking, team building, efficient. Then coming to my portfolio, these are the projects. This is my first project that I have done, like G+24 Mumbai residential project. It was a huge project and I think it was a great opportunity to work on such a huge project. It's located in Mumbai in the state of Maharashtra. Coming into the details of the projects, we have provided like raft foundation. Then the height of the building is about like 80.5 meters. These are the load considered: dead load, live load, dynamic wind gust load as per the codes, then the seismic load. So these are the analysis that we have performed on this project, like model analysis. It actually shows the nature or structure of the behavior. P delta analysis, it considers the lateral deflection, also the axial force on the structural stability. Coming to response spectrum analysis, is nothing but the structural response of the building against the ground, earthquake ground motion. Coming to buckling analysis, when the building is slender or the slenderness ratio goes beyond like 4, we used to conduct this buckling analysis. Auto construction sequence analysis is nothing but the impact of the construction load on the building. Stage by stage construction, it's a huge, complex analysis that's done in the field nowadays. Then coming to creep analysis, it's actually done for long-term deflection analysis. So these are these analysis that we have performed on this great building. Coming to the next building, this G+16 Mumbai. It's actually a commercial building. It's a flat slab structure. You may know that flat slab structure is a kind of structure where we used to have slabs and columns. There won't be any beams. Instead of beams, we would be using like drops. There are even two types of structure within the flat slab, like with drops and without drops. This building is having actually the drops. So it's a huge building. So coming into the building, we have done many checks on that. Again, we have provided the raft foundation this building because normally this kind of buildings would be huge. The building loads will be high, so that we have provided raft foundation for that. So what all checks, like we have provided, done all the analysis, we have done model analysis, we have done P delta, response spectrum, creep. It's actually a basic criteria for to be done for the slabs, flat slab structures. Coming to the checks, serviceability checks we have done here. So these are the interstory drift checks that are shown in these graphs. It's actually as per the code IS 1893. It should not go on beyond 1/250. Coming to these graphs, it's actually the maximum deflection against the wind. These two graphs, it's actually the maximum deflection against the earthquake. It's actually based on IS 16700. That's a tall building code for that. So these kind of checks we have done in this building. Coming to the next building, it's actually G+12 Andheri. It's actually based in Mumbai, Maharashtra. It's actually a residential building. Again, for this also we have provided like raft foundation. So we have done the analysis, model analysis, P delta, response spectrum, creep. We have done the checks, serviceability checks. We have done model checks. We have done irregularity checks. Like some of the irregularity checks, like torsion irregularity, that has to be done because it actually, what happens is that more the torsion, more the twisting of the building, it actually affects the model analysis. So model analysis, this chart is based on the model analysis. It's as per IS 1893, seismic design. Again, coming to next project, G+8 Mysore, again residential building, is based on the Karnataka, state of Karnataka, Mysore. So coming to this building, again we have provided like raft foundation. So the analysis we have performed, model, P delta, response spectrum. Again we have done the serviceability checks, stability model, irregularity checks. Again coming to the foundation system, if you see that it's almost like 180 kilonewton per meter square raft foundation we have provided. As per the code, we have to provide like 50 mm. Allowable settlement we have provided. Beyond that, all those things we have been doing with the software called SAFE. It's by CSI. So in that software we will be doing the ground bearing pressure check, again the settlement check, and the punching shear, reinforcement, crack width. All those things we are doing with that software. So coming to the codes, we are using like IS 456 concrete code, as you know, like IS 875 1987, the latest version 2015. So it's actually for wind. IS 1893, seismic again 13920, it's for ductile detailing, UBC 97. So this kind of international codes we are using like for certain certain conditions for the torsional irregularity. We have been using this kind of codes from the provisions we have been using from those codes. So the software we have been using, AutoCAD, ETABS, SAFE, and MS Office. Coming to this project, it's actually a different kind of project. So it's based on Pathanamthitta, state of Kerala. It's a retrofitting government project. Actually what happened was that it's actually an old building. So the government proposed the demolition, but a structural engineering consulting has asked for a chance of retrofitting, and we have studied about the building. We have done the NDT test on the building. Based on that, we have conducted like ultrasound, pulse velocity test, rebound hammer. This UPV test, it's actually done to test the quality of the concrete. Rebound hammer test we have done for the compressive strength. Core cutting test again to determine the compressive strength. Half cell potential test we have used to determine the corrosion of the reinforcement that's happening within the concrete. So this kind of test, based on these tests we will get the results. So using those results we will be modeling this building in the ETABS. So based on that we can identify the distress columns. So based on that distress columns, again we will analyze. So we will have that measures, retrofitting measures. So the field that we are measure that we are using is called jacketing. So this is the detailing of the column jacketing that we have done. So overall, to stabilize the structure, we have provided steel stress on the roof to avoid, because state of Kerala is actually more moisture based, rainfall is lot. So overall we have increased the life of the building to up to like 10 to 15 years. That was a great achievement. So apart from the checks, like we have done the PM ratio checks to identify how the columns are performing. So apart from that, this is also similar kind of government project. It's actually overhead water tank. So for this project, again we have done two things. Instead of just columns, we have also retrofitted the beams. So jacketing of the beam has happened, jacketing of the columns has happened. We have similarly done those tests like UPV test, rebound hammer, core cutting, half cell potential. Based on the results, we have done the analysis on the ETABS. Based on that, we have done the retrofitting. So so we have done the PM ratio test in this project too. So coming to next project, it's actually steel building. It's based on Visakhapatnam, state of Andhra Pradesh. It's an industry building. This steel project has been analyzed or designed using the software called STAADPro. So it's actually based on the Indian code of IS 800-2007. Those frames has been designed as per that code. Then the connection design we have been using manual. Also there's a software called Idea Statica we can do in that too. So for that also we have considered dead load, live load, wind load. So static analysis has been done. These are the materials that has been used for this building. These are the properties. This is actually the analysis. So these are the load combination that we have been using. So steel building, as you know, it's actually a wind governing structure. So rather than like gravity, we have to consider the wind as critical. So foundation we have provided like isolated footing, because normally this weight of the building would be less. So that would be sufficient for that. For isolated footing, as you know, it's like allowable settlement is 25 mm. So softwares like AutoCAD, STAADPro, SAFE, MS Office has been used. Again, this is a different kind of project, PEB structure. It's a pre-engineered building, industrial shed. So again, it's located in Visakhapatnam, state of Andhra Pradesh. Again, we have been using the same software called STAADPro. Again, AutoCAD we have been using. So here also the design code has been used as IS 800-2007. Connection design has been designed manually. Even we can use the software called Idea Statica for connection design. Dead load has been considered, wind load has been considered. So these are the wind load, load combination. This is the analysis result. These are the materials that have been used in this project. So coming to this material collection facility, it's actually a composite kind of structure. It's actually based in Kollam, state of Kerala. It's an industry building where we have provided, like the demand was that the building has been used as a recycling facility. So there is a fire hazard. So the fire rating should be more. So instead of RCC, instead of steel columns, we have provided like RCC columns. For the roof, we have provided just like truss. So it's actually a composite structure. This is a detailing of the roof truss. This is a detailing of columns, beams. This is a layout, and this is a detailing of. Along with that building, we have provided a office building too. All those checks we have done in foundation system. We have provided like isolated foundation codes. We have used like 456, 875, 8093. Softwares we have been, apart from the normal software, we have been using the RCDC. It's a great software for detailing. So detailing projects we have done using those software too. So coming to this project, this is a G+5 Mumbai project. So it's a residential building. It's located in the Mumbai, state of Maharashtra. Actually, the SBC of this soil is great. So it's like 300 kN per meter square. So that we have provided like isolated and combined footing. It's more economical compared to like raft and pile. So we have done all those analysis, model P delta, response spectrum, creep, and the serviceability checks we have done. So these are the results of that. Again, coming to next project, G+4 HSR Bangalore. It's actually a commercial building. It's based on state of Karnataka. So we have used a different kind of foundation here, like eccentric strap beam foundation has been used. Here the allowable settlement, just like the isolated, it's like 25 mm. Then these checks and analysis has been done. Again, coming to next project, this G+2 Nelamangala Convention Center project is actually based on state of Karnataka, Bangalore. Actually, the specialty of this project is that it's actually a deflection governing structure. So we have provided like deep beams to resist those deflection. Creep analysis has been an important analysis for this to determine the long-term deflection of this building. So in that way, we have arrested to a certain extent the deflection. Then we have provided like pre-campering to reduce the deflection on the building. Then we have provided like isolated footing. All those checks has been done in this project too. Then this is the G+2 apartment residential building. It's based in Trivandrum, state of Kerala. Again, we have been, you can notice here that the SBC of this soil is very less. It's less, about 100 kN per meter square. So we have to provide, no other way, we have to go with the pile foundation. We have provided this the pile layout, this is the beam layout, and this is the column detailing and beam detailing. We have been using the softwares like RCDC, ETABS, and SAFE. So we have conducted all those checks, serviceability checks, and all those analysis. Coming to this G+3 office building, it's a zonal council building. It's based in Trivandrum, state of Kerala. Again, it's a government building. We have provided like two kind of foundation. You can see here. There's a raft foundation at the center, and on both the sides we can see the isolated footings. So again, we have provided the detailing of the raft So you can see that raft beams are also provided on this project. So we have used softwares like AutoCAD, ETABS, SAFE, RCDC. Then coming to next project, it's like G+2 Tumkur residential project. It's a normal type of building. We have considered all those things that has to be considered here. So finally, you may reach out to me using my Gmail. This is my Gmail, this is my contact number, and you can scan this QR code to get my resume, or else you can just click on here and you may get my resume. To connect me or directly message me, just click on this LinkedIn link and you can directly contact me. Thank you.